equation of continuity. It's also known as law of continuity. You see, it's based on conservation of mass. For the fluid entering a pipe and coming out from that pipe, both should always be equal. Because of conservation of mass, we have the idea whatever the mass will enter over here, that will have to be coming out. Now, we could say the same in terms of law, that product of area and velocity is constant throughout. That's the simplest form of law of continuity. But let's see step by step. You see, this is A1, V1, this is A2, V2, and the fluid that is in motion is having the density D. You know, area into length is volume, and if you divide it by T, it becomes rate of flow of volume. That's volume entering per second. If you divide it by the density, you see, V into density upon time, this becomes the rate of flow of mass. Whatever the rate is entering, that will come out also. So you could say m1 upon t, that is equal to m2 upon t. m1, that is v, in place of v you could write a1. So v1 d or rho, this is v2 d or rho, this will be cancelled and it becomes a1 v1, that is a2 v2. This rate will also continue, and v1 upon t, that is equal to, here I have written v1 upon t, this is a into velocity. So a1 v1 equal to a2 v2. This is law of continuity. It could be summarized as a into v, this is constant. Or you might say is proportional to 1 upon v. If you plot a graph between a and velocity, you will find a rectangular hyperbola. You see, this law has many practical applications in our daily life. Arteries and veins, if you compare, arteries are comparatively narrower and you'll find the velocity of the blood greater over there. Similarly, if there is a river and that becomes narrower in some particular part there, when the area gets reduced, the velocity has to be greater. And that is what actually we observe with the narrower gauges of the river or wider valleys. We see this kind of change. Where the valley is wider, the velocity becomes lower. When the gauges are narrower, the velocity becomes higher. You see, similarly, when we define law of continuity, we have to keep in mind that this is another outcome of law of conservation of mass. Do remember, whenever the area will decrease, velocity will increase, area increases, velocity will decrease.